Good day to all of you. We are Group 2 from St. Thomas of Aquinas. Yours truly, Kerwin Kilang, together with Cleoford Alvarez, Clyde Bawagan, Hannah Balderramos, Gwyneth de la Peña, and Justin Navarro. In this video, we're going to discuss about circular functions. But before anything else, let me present to you our lesson's objectives. First, unlock definition of terms. Second, identify the 6 functions of a circle. Third, determine reference angle of a given angle. Lastly, identify the circular functions of a given, either degree or region, using the reference angle. We have here our concept map. Our general topic is circular functions. The two main branches of circular functions is circular functions on real numbers and the reference angle. Combining these two ideas, we can come up with our application to find the exact values of circular functions. First, let's know how circular functions started. The use of trigonometric functions arises from the early connection between mathematics and astronomy. Early work with spherical triangles was as important as plane triangles. The first work on trigonometric functions related to chords of a circle. Given a circle of a fixed radius, 60 units were often used in early calculations. Then the problem was to find the length of the chord subtended by a given angle. The first known table of chord was produced by the Greek mathematician Hipparchus in the early 140 BC. We define circular functions on real numbers as the functions whose domain are the set of numbers that correspond to the measure of angles. Also, ranges of circular functions are the set of numbers that are real numbers. Trigonometric functions are often called circular functions interchangeably because the region measures of the angles are calculated by the arc length of the circle. And in this lesson, we will modify these trigonometric functions so that the domain will be real numbers rather than set of angles.
Since we're tackling about circular functions, it is a given that we are dealing with triangle. But where do those came from? Let's draw a coordinate plane and a circle. The circle is cut into 4. The vertical line is the y-axis and the horizontal line as the x-axis. Let's draw a radius. Let's recall radius as the line from point center to circumference is equivalent to 1 in unit circle. Let's try to move it in quadrant 1. Whether we stop, we can draw a line from the endpoints of the radius to the x-axis. Then, a triangle. Note that it will always be a right triangle. There is an y leg and an x leg. The radius will be the hypotenuse. As the radius moves, observe that the radius has still the same size, but the size of the legs change depending on the angle. When it's past the vertical lines, the angles is now in quadrant 2. As it passes the negative x-axis, the angle appears in quadrant 3, and lastly to quadrant 4. To describe the exact connections between the side length and the angle, we can use the circular functions. Let's look at the triangle. We have the hypotenuse and the leg, the adjacent, the leg right next to the circle, and this another leg would be the opposite. Here comes our 6 circular functions. We can say that sine of theta is equal to the length of opposite over length of hypotenuse, or it is equal to y. Next, cosine of theta is equal to the length of adjacent over hypotenuse, or it is equal to x. And the tangent of theta is equal to opposite over adjacent, or it is equal to y over x. This is summarized by SOHCAHTOA. SOC for sine opposite over hypotenuse, CAH for cosine adjacent over hypotenuse, and TOA for tangent opposite over adjacent. The next 3 circular functions are cosecant. It is the reciprocal of sine functions, hence we have hypotenuse over opposite, or 1 over y. Another is secant. This is the reciprocal of cosine functions and it is equal to hypotenuse over adjacent, or 1 over x. And lastly, cotangent. This is the reciprocal of tangent functions. It is adjacent over opposite, or x over y.
Let's now visualize the 6 circular functions. Sine function can be defined as the ratio of the length of the opposite side to that of the hypotenuse in a right-angled triangle. The sine function is used to find the unknown angle or sides of a right triangle. Next, cosine function. In a triangle, it is the ratio of the adjacent side to that of the hypotenuse. Next is tangent. It is the ratio of the opposite side and the adjacent side of the angle in consideration in a right-angled triangle. Now, to the reciprocal functions. The reciprocal of sine is cosecant function. It is that for an acute angle, it is the ratio between the hypotenuse of a right triangle, of which the angle is considered part and the leg opposite. The opposite of cosine, secant. Secant function is the length of the hypotenuse divided by the length of the adjacent side. It is a straight line joining 2 points on a function. Lastly, the opposite of tangent. Cotangent is the ratio of the length of the adjacent leg to the length to the opposite leg.
Now let's move from the summary of deriving the circular functions. But before that, let me give you some information about theta. The Greek letter theta is used in math as the variable to represent a measured angle. Suppose theta is an angle plotted in standard positions and P, X, Y, theta, which lies on the unit circle. Again, here are the 6 circular functions. Sine is equal to y, cosine is equal to x, tangent is equal to y over x, secant is equal to 1 over x, cosecant is equal to 1 over y, and cotangent is equal to x over y. The number 1 in secant and cosecant is the value of the radius, which is always 1 in the unit circle. And also always remember that when we are dealing with fractions, especially tangent, cosecant, secant, and cotangent, the denominator must not be equal to 0. So if the denominator is equal to 0, the values will be undefined. Lastly, the denominator should not contain any radical sign.
Before we proceed, let's know the terms relating to the unit circle and circular functions. Any of a group of functions of an angle expressed as a ratio or degree of 2 of the sides of a right-angled triangle containing the angle. The group includes sine, cosine, tangent, secant, cosecant, and cotangent. First, we have degree. Degree in full. A degree of arc or arc degree is usually denoted by the degree symbol. It is a measurement of a plane angle in which one full rotation is 360 degrees. Second is radian. It is a unit of measure for angles that is based on the radius of a circle. It is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of that circle. We commonly see radian associated with the symbol pi. Both the degree and radian are units to measure an angle. Next, we have terminal points. It is also called as trigonometric points. It is the coordinate of the endpoint or the point you end up at. It is denoted by P of theta is equal to x, y. Terminal points are commonly seen as with a radical sign. These points must be identified from angles and use this to determine the 6 circular functions. We normally need to use the calculator to figure out the values of the trigonometric functions of an angle unless we are dealing with trigonometric special angles, because it is not possible to precisely evaluate the trigonometric functions for most of the angles. But, is it true? For all the angles, the answer is no, not always. The table you can see is the list of special angles. There are specific angles such as 0, 30, 45, 60, and 90 degrees that provide simple and exact trigonometric values. These specific angles are known as trigonometric special angles. These are commonly used and encountered because it is easy to exactly evaluate the trigonometric function without using a calculator for these angles. The signs of circular functions, either positive or negative, depends on which quadrant the angle lies. In quadrant 1, the x-axis and y-axis are both positive. Therefore, All circular functions are positive. In quadrant 2, the x-axis is negative and y is positive. Only sine and cosecant functions are positive. In quadrant 3, the sign of x-axis is negative and the y is negative. Both are negative, so only tangent and cotangent functions are positive. The last one is quadrant 4. The x-axis is positive and the y is negative. Hence, only cosine and secant functions are positive. Remember that each of the 6 circular functions have different formula and angles may be in different quadrant. This determines the appropriate sign of the function being obtained.
Reference angle. A reference angle of an angle is the smallest positive acute angle formed between terminal side and x-axis. In other words, the reference angle is an angle that is in the middle of terminal side and x-axis, and it must be less than 90 degrees and must be always positive. As you look in the shown picture, the reference angle is in the middle of terminal side and x-axis. Regardless of where the angle ends, the location of the terminal side of an angle, the reference measures the closest distance of the terminal side to the x-axis. Standard position. Standard position is the location of an angle such its vertex lies at the origin, and its initial side lies along positive x-axis. The difference between standard angle and either 90, 180, 270 or 360 degrees depending on the location of the angle. Terminal side. Terminal side is the ray where measurements of the angle stops. It can be anywhere it defines the angle. It means that the side of an angle after rotation, the final position of the ray whose rotation created an angle. Initial side. Initial side is the side of an angle from which the rotation begins, or the initial position of the ray whose rotation creates the angle. Vertex. The vertex is the common endpoint of two rays that meet at a point to form an angle. Take note that vertex is always placed at the origin. Remember, the reference angle is between the hypotenuse of triangle form and the x-axis. It is the difference between standard angle and either 90, 180, 270 or 360 degrees depending on the location of an angle.
We have an important note that theta is the given angle. These are the formula in getting the reference angle. It depends on which quadrant a given angle lies. In quadrant 1, reference angle is equal to the angle it lies between 0 degrees and 90 degrees. So the reference angle formula is d theta, or the given angle itself. For short, it will always be the same as the standard position in quadrant 1. In quadrant 2, if the angle lies between 90 degrees and 180 degrees, then the formula is 180 minus the given angle. In quadrant 3, if the angle lies between 180 degrees and 270 degrees, then the formula in getting the reference angle is given angle minus 180. Lastly, in quadrant 4, if the given angle lies between 270 degrees and 360 degrees, so the formula for the reference angle is 360 minus angle.
Remember that reference angle is always positive.
Let's have some practice. Determine the reference angle of the following: 45 degrees, 110 degrees, 210 degrees, and 300 degrees. Example number 1. We need to determine the reference angle of 45 degrees. Since 45 degrees is in quadrant 1, hence our reference angle is also 45 degrees. Next, we have to find 110 degrees. So, if our given angle is 110 degrees, then its reference angle is 180 degrees minus 110 degrees. And we will have reference angle of 70 degrees.
Example number 3, 210 degrees. 210 degrees is in quadrant 3. Therefore, our formula is given angle minus 180. 210 minus 180 is equal to 30 degrees. Our reference angle is 30 degrees.
Example number 4. We have to find the reference angle of 300 degrees. 360 degrees is in fourth quadrant, and our formula for that quadrant is 360 minus the given angle. Therefore, 360 minus 300 degrees is equal to 60 degrees. But what if the given angle is a negative angle? We will have a different formula in determining the reference angle of a negative angle. First, we need to find the positive coterminal, and second, use the coterminal to get the reference angle, theta plus k times 360. Coterminal angle are angles that have the same initial and terminal sides. In theta plus k times 360, theta stands as for the negative angle given. K is the number of rotation and 360 degrees is constant in this formula because that is the measure of a full rotation. For example, find the reference angle of negative 330 degrees. Let's use the formula. For theta, we have the given negative 330 degrees plus we have only one rotation because negative 330 doesn't exceed negative 360 degrees, and then multiply the single rotation to 360 degrees. 1 times 360 is equals to 360. Then add negative 330 to 360. Therefore, we found out that negative 330 degrees is coterminal with 30 degrees. Then use the 30 degrees to find the reference angle. Since it is in quadrant 1, then our reference angle is also 30 degrees. Last example. Find the reference angle of negative 510. Let our theta be negative 510. Question: how many rotations do we have in negative 510 degrees? The answer is 2 rotations because negative 510 exceed in single rotation negative 360 degrees. Why do we need to consider the rotation? Because we only add 360 or a single rotation, then the angle will be also negative. That is not what we want because reference angle is always positive. So 2 times 360 is equal to 720. Then let's add negative 510 and 720. We will have a coterminal of 210 degrees. Let's use it to find the reference angle. Since 210 degrees is in third quadrant, we'll use the formula angle minus 180. 210 minus 180 is 30 degrees. Hence, 30 degrees is our reference angle.
Evaluating circular functions using reference angle. There are 4 steps in evaluating circular functions using reference angle. These are the following. First is to find the reference angle for the given angle, or region, or terminal point. Second is to write the original trigonometric function with the reference angle. Third is to affix the appropriate sign to the trigonometric function, positive or negative, depending which quadrant the angle terminates in. And lastly, evaluate or determine the trigonometric functions. But before everything else, let's know how to convert region to degree and degree to region, which we may use depending on the given. So here's how we convert degree to region and region to degree. In converting degree to region, we need to multiply it by pi over 180. And in converting region to degree, we need to multiply it by 180 over pi. Now let's try this example. First, we have 78 degrees. And since our given is degree, we are going to convert it into region by multiplying 78 degrees to pi over 180. Then we're going to simplify it. Using the cancellation method, we are going to cancel 78 and 180. Then 78 will become 13 and the 180 will become 30. Then next, we will multiply 13 to pi. So we will have 13 pi all over 30. And our next example, we have 43 pi all over 90. And since our given is region, we are going to convert it into degrees by multiplying 180 over pi. Then we're going to simplify it. Using cancellation method, we're going to cancel 90 and 180. Then 90 will become 1, and then the 180 will become 2. Then next, we will multiply 43 to 2, so we will have 86 degrees. Now, let's identify the circular functions of the following. For example, we have 150 degrees. First, we need to find the reference angle of it, and since 150 degrees is in quadrant 2, we will have 180 degrees minus 150 degrees, and we will have 30 degrees. Next, we will find the x and y value of 30 degrees. Since we have 30 degrees, we will have a square root of 3 over 2 for x coordinate and 1/2 for y coordinate. Then next, we will affix the appropriate sign. And since 150 degrees is in quadrant 2, it means we will have negative and positive. So now we need to change the sign of these points. So our x-coordinate will be negative square root of 3 over 2, and y-coordinate is still positive 1/2. Then after that, we will now solve the 6 trigonometric functions. For sine of 150 degrees, we will just have our y-coordinate since sine is equal to y. So for our sine 150 degrees, we will have 1/2. For cosine of 150 degrees, we will just have our x-coordinate since cosine is equal to x. So for our cosine of 150 degrees, we will have negative square root of 3 over 2. For our tangent of 150 degrees, we will have our y-coordinate over x-coordinate since tangent is equal to y over x. And now we have 1/2 over negative square root of 3 over 2. So let's just solve this. 1/2 multiplied by the reciprocal of our denominator, negative 2 over square root of 3. The 2 will be cancelled, then we will have negative 1 over square root of 3. And we have to rationalize. So multiply both numerator and denominator into square root of 3. Then we will now have a negative square root of 3 over 3. And for the other 3 trigonometric functions, the cosecant, secant, and cotangent, we all have to do is to get the reciprocal of the first 3 functions. For cosecant of 150 degrees, this is just the reciprocal of sine of 150 degrees. And since our sine of 150 degrees is 1/2, therefore our cosecant is 2. For secant of 150 degrees, we will have the reciprocal of cosine of 150 degrees, and since cosine of 150 degrees has negative square root of 3 over 2, so therefore it is negative 2 over square root of 3. And then we have to rationalize this. So multiply both numerator and denominator by square root of 3. So we will get a negative 2 square root of 3 all over 3. And for the cotangent of 150 degrees, we will just get the reciprocal of the tangent, which is the negative square root of 3 over 3. Therefore, we have negative 3 over square root of 3, and then we have to rationalize this. So multiply both numerator and denominator by square root of 3. And we have negative square root of 3 over 3. Then we can still cancel the 3, and we will get a negative square root of 3.
Next, identify the circular functions of theta negative 855 degrees. Since the given is negative, we need to find the positive coterminal. Let's use the formula theta plus k times 360. Let our theta be negative 855, and since negative 855 is within the third rotation, then we will have 3 as k. Then, we will multiply it to 360. So 3 times 360 is equal to 1080. Let's add negative 855 and 1080. Then we will have 225 degrees. Let's use this coterminal, 225 degrees, to find our reference angle. Since 225 is in third quadrant, our formula is going to be given angle minus 180. So, 225 minus 180 is equal to 45 degrees. That is our reference angle. Next, let's use the unit circle to find the terminal points of 45 degrees. Our terminal points or coordinate is square root of 2 over 2 and square root of 2 over 2. Next, we have to affix the appropriate sign. Since negative 855 degrees is in third quadrant, we have to change the signs into negative and negative because there, x-axis and y-axis is negative. So it will become negative square root of 2 over 2 and negative square root of 2 over 2. After getting the terminal points, let's now identify our 6 circular functions. Let's begin with our sine negative 855 degrees. Sine is equal to y. Coordinate is negative square root of 2 over 2. Next, let's find the cosine of negative 855 degrees. That is the x-coordinate of our terminal point. Then we will have negative square root of 2 over 2. Next, let's find tangent of negative 855 degrees. Our formula in tangent is y over x, so we need to divide negative square root of 2 over 2 by negative square root of 2 over 2. If we will divide this, we will have 1. Next, let's identify the secant of negative 855 degrees. Secant is the reciprocal of cosine. We need to rationalize this because there should be no radical sign in the denominator. All we have to do is to multiply the denominator to the numerator and the denominator itself. We can cancel 2 in the numerator and the denominator, and what's left is negative square root of 2. That is our secant. Next, let's find our cosecant of negative 855 degrees. Cosecant is the reciprocal of sine, so we will have negative 2 over square root of 2. Again, the denominator should not contain any radical, so we need to rationalize this. We need to multiply the numerator and the denominator to the numerator. Negative 2 times square root of 2 is equal to negative 2 square root of 2. Square root of 2 times square root of 2 is equal to square root of 4, and that is 2. Then what's left is negative square root of 2, and that is our cosecant. And for our last circular function, cotangent of negative 855 degrees, it is the reciprocal of tangent. So, 1 over 1 is the reciprocal of our tangent. And 1 over 1 is also equal to 1. For our last example, identify the circular functions of the radian theta is equal to 4 pi over 3. The given is in radian form, so we can convert it to degrees. Our formula is radian times 180 over pi. We can factor 3 and 180, so 3 will become 1 and 180 will become 60. Let's cancel pi and multiply 4 by 60, and that is equal to 240 degrees. Now let's use 240 degrees to find our reference angle. 240 degrees is in third quadrant. Formula is given angle minus 180. So 240 minus 180 is equal to 60 degrees. Our reference angle is 60 degrees, and let's use it to find our terminal points. From our unit circle, the terminal points of 60 degrees are 1/2 and square root of 3 over 2. 240 degrees is in third quadrant, so x-axis and y-axis are negative. And we need to change the signs of our coordinates into negative. So it will be negative 1/2 and negative square root of 3 over 2. Now, let's use this to determine our 6 circular functions. Let's begin with sine 4 pi over 3. Our sine is the y-coordinate, so we will have negative square root of 3 over 2. Next, let's find our cosine 4 pi over 3. And that is our x-coordinate, which is negative 1/2. Next, let's find our tangent of 4 pi over 3. That is y over x. So we will have negative square root of 3 over 2 divided by negative 1/2. Let me share to you this technique. In dividing these two coordinates, we can simply cancel the denominators. Let's cancel 2. And let's also cancel the negative signs. What's left is square root of 3 in the numerator and 1 in the denominator. So our tangent will be square root of 3. Next, cosecant of pi 4 over 3. Cosecant is the reciprocal of sine, so we will have negative 2 over square root of 3. We need to rationalize because there is a radical sign in the denominator. So let's multiply this by the numerator. Negative 2 times square root of 3 is equal to negative 2 square root of 3. And let's multiply square root of 3 by square root of 3, and that is square root of 9, or simply 3. Next, let's find our secant of 4 pi over 3. Secant is the reciprocal of cosine. From that, we will have negative 2 over 1, or in simplified form, negative 2. And last circular function, cotangent of 4 pi over 3. That is the reciprocal of our tangent. The reciprocal of square root of 3 is 1 over square root of 3. We have to rationalize because we have radical sign in the denominator. So we need to multiply this by the value of the denominator. 1 times square root of 3 is equal to square root of 3, and square root of 3 times square root of 3 is equal to square root of 9, or in simplified version, it is 3. For the summary of this discussion, remember that circular functions are any of the group of functions of an angle expressed as a ratio of 2 of the sides of a right-angled triangle containing the angle. Remember that there are 6 circular functions, and these are sine, cosine, tangent, secant, cosecant, and cotangent. We also have a reference angle. Reference angle is a positive, acute angled form between the terminal side and the x-axis. Another, in circular functions and reference angle, formula and sign are different depending on the quadrant where the given lies. And remember that there are 4 steps in determining circular functions, and these are the following. These are the reference used for this discussion. That's all, and thank you for listening.